Hello and welcome to this Micrographics webinar. We will be beginning shortly, so stay tuned. Alright, I think everyone's here, let's go. So today's topic, guys, is going to be on Autodesk Inventor and introduction to the mold design environment. My name is Irshad Hanif. I'm an application engineer with Micrographics, and I'll tell you a little bit more about myself later on. So, what is the purpose of today's webinar? Well, today's webinar is going to be a fairly quick one, and the purpose is to give you a very high level overview of the mold design feature in Inventor Professional and do a brief discussion of its features. It is not a tutorial. There's quite a lot of things that we can see in the environment. I mean, to do a full mold design that's proper and works will take many hours, and that's not what we want to do. Right now we just want to show you what can you do and how intensive it is and how in-depth and granular it can get. The features are very great for people in the industry of mold design and plastic part molding. Okay, so let's take a look at our agenda. We're going to start off with a basic instruction, explanation of what mold design is. We're going to look at the mold design environment, how you can access it, where you should be looking for it. Then we're going to take a look at the process, which starts with core and cavity, plastic part in mold design, feeding system for molten plastic, a cooling system for molten plastic, and of course the analysis tools that are available in your mold design layout tab. Alright, like I said, I'm just going to tell you a little bit more about me and Micrographics, the company that I work for. My name is Irshad Hanif. I'm an application engineer with Micrographics with approximately 10 years of experience in CAD, CAM, and mechanical engineering. Primarily, I've worked as a process engineer and mechanical manufacturing engineer. My main areas of expertise are going to be AutoCAD, Inventor, Fusion 360. Of course, I expand my capabilities to CAM, FEA, design and modeling, as well as product data management. So things like Autodesk Vault will be part of my expertise as well. And I'm also a Autodesk certified professional. Okay, enough about me. Let's get started with the introduction. So what is mold design? Well, mold design is a feature set built into Inventor Professional that allows you to generate accurate molds from your design models. So you can have your plastic part design in Inventor and immediately take it to a different workspace that will design a mold around it. Nice thing about it is that it has intelligent mold specific tools and catalogs for you to pull out parts. Although there are some caveats to that, and we'll get to that in a second. You can also put in standard components and put in vents and cooling channels and what have you. Anything that's necessary for the mold design process, you can pretty much do it in the mold design environment. And lastly, of course, you can perform an analysis, and all the tools in every single ribbon will guide you through the design process. So let's take a little bit of an in-depth look at the features of mold design. So like we just said, we've got mold flow analysis. We've got family mold, where you can mold a family of parts. We've got runner and gate options. We've got options to put in cooling channels as well as cooling components. Then of course we have the automated core and cavity design, which is the basis of the mold design process. And we have tools to allow with your drawing automation. As mentioned earlier, we have standard component tools and libraries, so things like standard materials, standard tool libraries. We also have customized as well as standard mold bases to start with. For example, They might have a Futsaba mold base that you can customize according to your needs for what components you would like to include when you're inserting your mold bases. And lastly, we've got the main feature set here, which is full associativity, meaning that any changes are adaptive. If you make a change on the base of your mold, it will adjust to the top of your mold as well. So it's fairly adaptive. Alright, so let's take a look at the mold design environment. How would I access the mold design environment? Well, if you're not familiar or if you've never used it before, you're going to look in your environments tab for a button called create mold design. Now this is only going to be found in your part mode, so in an IPT, not in an IAM. So a lot of people will have a full assembly and they'll say, hey, I want to create a mold for this. Yeah, you're not going to find it in your assembly mode. Right, so go open the individual part that you would like to make a mold for, and then you'll find under the environments tab your create mold design. Once you click on that, you'll find that it opens a contextual ribbon with a bunch of extra tabs that you haven't seen before. One will be called mold layout and the other will be called mold assembly. Now, the Inventor mold fill analysis is not available in 2022 onwards, right? So this has been removed, so I've just put in a note just to make everyone aware. You might be working on Inventor 2023 and try and follow along on some tutorials on the internet, but the tools provided with Inventor for mold simulation, analysis and material assignment are removed for 2022. What was the reason for this? Well, the material library was out of date, well, for one, and also the analysis portion of the tool was a 32-bit software, and this presented a possible security risk for going forward in Inventor 2023 and onwards, so it has been removed. According to Autodesk, you should continue using 2021, or you can download and use Moldflow Advisor from your manage.autodesk account if you still want to carry on in the newer versions. So let's take a look at how we would go about setting up our model. Right, so once you enter this contextual menu in your ribbon, you'll find under the mold layout tab, you want to define your orientation. This will basically define which way the top and bottom half of your mold splits. Right, so you'll probably have to click on an axis and say split along this way or split along this axis. Right? We'll take a look at how to do that exactly in the demo, but that's just the first step. The second step, and super important step, because things like analysis will depend on this, is to define your material. Now there is a library of standard plastic materials, but like we mentioned earlier, this library may not be up to date, hence it was partly the reason why it was removed from the current versions. Right? And lastly, in order to for your mold to understand how it would flow eventually if you do perform analysis, you would need to define your gate locations, your cooling channels and stuff like that. So you'll adjust parameters for the insertion of your molten plastic. Okay, let's take a look at the core and cavity method, or the core and cavity toolset rather. Once you've done with the basic setup, you've adjusted the orientation, you can go in and set up the workpiece, which is basically, if you've done any sort of CNC machining, it's basically similar to your stock, so your stock material. So you'll define the material that you're working with, right? Define your workpiece, and then you'll find tools like create a patch surface. So inside of your part, if you have any holes or stuff like that, there's a lot of plastic molds that will have holes for screws or just basic gaps for other parts. You would need to create a patch surface because it needs to understand that is one complete fold out surface that it's parting. Right. Lastly, you would need to create a runoff surface, which is basically the point at which the top and bottom half of the mold splits. Again, We'll take a look at how to do this exactly in the demo at the end, but for now you can just understand the process from these pictures. Okay, let's move on to the feeding system under the mold assembly tab. So you'll start off here by selecting your mold base, and you'll be able to customize that mold base. So the first option there is to select from a library. If you see the first button on the left of the ribbon, that will be the mold base, and you'll see it insert a standard, in this case I think it's a Futsaba mold base, where you can define exactly how many pins and other components or subcomponents you might want to include. So if you don't need a specific layer of it, you can simply just remove it from the assembly. It's very configurable. On top of that, you can add your own uh, external components, things like ejectors, sliders, lifters, and cooling components. So in this menu, this is where you'll add all of that. You can see the tools there directly. Of course, like I said, this is not a tutorial, so we won't go through everything. It's quite involved, but this is what you can do in case you're wondering, or you haven't used Inventor multi-site before. So let's take a little more of a deeper look into the cooling system. So you'll be able to add cooling channels, right? And you can do this in a variety of ways. You can create a sketch and say I want cooling channels to follow these lines that I've drawn on a sketch, and maybe pattern them around. You can create cooling channels between two linear edges, so you can just click on one edge and the other edge and say create a cooling channel from here to here, and it will create a channel that goes straight between those two edges. And lastly, once you've got an edge, you can create an offshoot, or from an existing channel you can add a cooling channel that extends outwards or in any other direction. Right, so you can see I've highlighted there, they've got these cooling channels, and at the end they've got cooling components. So there are 8 type of cooling components that we can add, and they are listed there: baffle, cascade water junction, connector plug, heat transfer pipe, O-ring, pipe plug, sealing plug, and spiral core. Now, I'm not gonna beat around the bush here. I'm no expert when it comes to injection molding. I have limited experience in industry, but of course people that do work in this industry will know exactly where and how to use these according to the criteria they need. But it's all automatically from the add cooling component tool that exists in the ribbon for mold design. Alright, the last thing we can look at is the analysis. So we can perform a mold flow analysis from the mold layout tab. So the analysis is going to be dependent on the material you selected. So very important to select the appropriate material, because they will pull out the appropriate settings which you can tweak in your particular analysis. For example, things like melting point and flow temperature, all of that will be pulled out directly from the manufacturing spec sheet, but you can tweak it for your liking if needed. Right? You'll also need to run a part process analysis to define those features and set it. Now remember, everything will get recorded on your browser tree on the left, so you can see I have there where my cursor is right now the process settings, the part process settings, which I can go and edit and change each time for different studies. Okay. And lastly, I can click the part flow analysis to analyze exactly, okay, based on these settings with this material, here's how it will flow. And the part flow analysis will show you the following. It will show you the fill time, again very much similar to something like FEA, where it shows you the heat map of the maximum stresses. Here under each subcategory, fill time, plastic flow, confidence of flow, it will show you a heat map of the highest and lowest areas. For example, in the picture I have included the fill time in the graphic window, right? So that will show you the parts where the longest fill time is needed based on where you've placed your injector pins. Alright, so you have full-time your plastic flow, the confidence of flow, air traps, quality, and weld lines. Okay, let's take a look at a demo. Again, very high level overview, not a substitute for a full-on tutorial, as that will take a really immense amount of time. I'm going to start with the part here. You can see I've already done one in preparation for this demo, but let's do it again from scratch just to show you how we go from 0 to hero. So I'm going to go to my environments tab in part mode, so this is the part in question, and I'm going to go to create mold design. It's going to ask me to give it a name. I'm going to say skip and give it that mold design 2, that's fine. Right, you'll see up there the contextual menu, and basically everything is grayed out when you start because it's just taking you to the mold design environment, but it doesn't know yet which part you want to include or need to be made a mold for. Okay, so you'll see the only button here is either to pick a part, meaning open one from the file menu, or to click something on your graphic window. So I'm going to click this one on my graphic window, and immediately it's going to want to generate some part names for all the components. Right, I have Vault, so I've got these automatic file name generators, so I'm just going to say skip on that for now, but it will generate the 3 main parts. You'll see on my browser it has appeared, and okay, it is now preparing me for creating my mold. Right, so like we said in the slides, first thing we want to do is we want to adjust our orientation. Make sure we know which way is Z and which way it's going to split apart. So if I go to adjust orientation, you'll find, oh, here we go, it is looking incorrect. Okay, it's going to want to open this way, whereas we want to open that way. So I'm going to say, okay, my Z should actually be from a extension line here. So we can say, that's better. So what I've done is I've clicked the Z-axis, must point upwards, and I've clicked from that face pointing upwards. Remember, in most things like CAM or Inventor, whenever you set up your orientation, if you click on a face, it's going to go perpendicular to that face. So I said Z-axis perpendicular to that face, and boom, you've got the Z-axis. So now it says opening direction up this way, and that's pretty much what I wanted to do. So I'll say okay. Okay, so it's reorientated the part. Next, I can go ahead and select my material. Remember, we said it will bring up the material library selector, and you'll find you have a whole list of manufacturers. It's quite extensive, although according to Autodesk it hasn't been updated in a while, and that's one of the reasons it was discontinued. Okay, so we can choose something like that as an example. Okay, so now we've got a material, and we've got the part orientation. So you can see very much similar to other studies like FEA or CAM and stuff like that, where you select a material or define your orientations and so on. Okay, now we can move to actually creating our core and cavity. Right, so I'll click on the core and cavity button in the mold layer tab. It'll bring up a further contextual menu. So like I said, the reason this is not a tutorial, it can get quite involved fairly fast. So I'm just going to show you briefly what I've done. If we do want to, we can readjust our orientation, but that's not necessary now. What we need to do, however, is fix any holes if they are, because if there's any holes, that's going to cause problems. In my particular design that I have here, which I just made up, I don't have any holes, but if I did, I will have to go and create patch surface, where I can say patch everything on a particular surface. So if there was a hole there or a hole there, it would patch it up. Right now what I want to do is I want to first create a runoff surface which will define my parting line. So I'm going to click on the runoff surface tool. I need to create a workpiece first, my bad. So basically I need to create like that stock material. So let's go ahead and do that first. Simply click on the define workpiece setting, and you'll find that it will say, okay, what is your total workpiece? So I can say, alright, based on these, let me lock it at, okay, I know my X, I can look at my triad, my X, Y, and Z. So let me make my X a little bit wider. I'll say 250. Right. I'll make this one a little bit narrower. I'll say 300. Right, and that will should be my my workpiece setting. Right. Again, depending on the shape, it will automatically pick up what's the best shape. So if you have some sort of a cylinder, you can say cylinder, or a reference you can do by bounding box, or you can have by references where you say so many mils above the top or stuff like that. Right. But I would just say by bounding box, and I give it the absolute dimensions. Oops, it has reverted to normal. Alright, so I'll say 300 and 250. Right, here we can lock these so that they don't change in later studies, and once we're happy with that, we can say okay. Again, it's going to ask me to name it and save it, and you'll find that I now have a workpiece defined. I can create another one if I choose to modify the settings. Alright, from that I can go in and say, okay, from this workpiece I need a parting line to split this entire workpiece. That will create my mold, and that will be the creating of the run-off surface. So I'll say, okay, cool, I'm going to create a run-off surface, and I will just use the outer edges of my part from here. And that looks good, so I'll say, alright, all extending out in that way, so that's going to be my parting line. I should be happy with this, so I'll say, alright, it's going to create a run-off surface. That's what it's going to do. You can see this is what we're planning to do, and I'll say, alright, cool, using these criteria generate a core and cavity for me. Right, so when I click on the core and cavity button, I can go to preview and diagnose and say, alright, let me just separate it to see. Okay, cool, so the green is the top half and the blue is the bottom half, and it's going to create this mold. You can see it's sort of the inverse of my part, which is exactly what I need. And when I'm happy, I'll say okay. It's going to ask me again to save all the names for the files. Okay, and here you'll see I have the core and cavity created. So once I'm done with this kind of setting, I can go and say finish core and cavity. Alright, and you look at your components, so these will be now individual components. So if I look at this, I can open it directly and say, whoa, oh, there we go, this is the bottom half of my mold. Let me go back to the other one. I'll look at the cavity, I'll say open. Now here we probably just want to maybe change the appearance or something like that. Let's make it generic. Okay, so here we can see this is what the top half of it looks like. So it's going to block out everything and create the mold shape that I wanted. Alright, now of course we can go back to our we can go to the next tab, which is your mold assembly, and the other tabs that I did say were tabs where you can insert a standard mold base. If you click on here, you'll find that you have a library to pick from, a standard mold base. You can look at all bases, whatever have you. Okay, so you'll find that they have standard sizes. Okay, so something like that. Okay, and you can use a placement reference. So I will use my placement reference as maybe that parting edge. So you'll see it's going to want to place in that orientation. You can rotate if you want to, but right now this is okay. But I think the standard mold base should be bigger, so we'll go in here. Maybe a little bit bigger than that. Yeah, alright, so we'll say okay. Now you'll see here there's a button for customize, which means if I don't want to see, each of these are a customizable piece of the mold, so I can say customize, and it will bring up a sub menu here where I can go and say okay, I can move this up to the top or move this down or take it away completely if I don't want to. So if I have this, I can sort of just remove it completely if I don't want to see it. So that any of these mold components in the jig can be removed at will. I'm just gonna say okay, again just for illustration purposes and not a full tutorial. Okay, it's going to take a while to pull in all the parts, but basically that's what it's going to do. Okay, so it's going to put in your complete mold settings, and this is essentially your mold base without having you to do much. You can always go back and edit it should you need, and at this point you can go in and add in any additional ejectors, sliders, lifters, or stuff like that. Now we did say we can add in cooling components. Right, so the cooling component menu looks like this, and you can say at a certain point here you want to add certain cooling components wherever you need to, although I'm not going to do any of that right now. We're going to keep it super simple just to show you the end result of what a analysis can look like. Okay, so if you go back to your layout tab, you can find that you can add in your cooling channels according to your sketch, and then lastly when you're ready you can add in your cooling components from the mold assembly tab, and you'll be okay. One critical thing you need to do before you even get to the analysis, which we're going to get to now, is you've got to define your gate locations, right? So you've got your runners and channels area here where you'll put in your gate locations. So I will say, right, I want to put in maybe some gate locations here. I'll say apply. You're going to see it's going to bring in your it's going to bring in the view very clearly so that it ignores the mold base, so that you can easily click on places on the model itself. And I'll try and put it on 4 corners just so we see what the effect is. So somewhere around here, right? Okay, so I'm inserting my gates in there. I'm not going to have any cooling channels in here right now, right? But what I can do is on my part I can go and double click on this, and I can look at a part fill analysis and go, okay, cool. In order to do that, I've defined everything I need to, which is the workspace, the splitting area. I've got a core and a cavity. I've selected the material so it knows what the settings are for the material. All I need to do is add a part process settings in order to tell it, according to the material, this is what my mold temperature and my melt temperature is, and I can define settings based on any study that I want. Right, so I'll say, once I say okay, you'll see it'll appear here. I have to define these. Right, once that's done, I'm ready to do a part fill analysis. So I can say okay, let's analyze that, and it's going to take a while, but not too long. I'm sure we can wait it out. You'll see it's gonna process the model. It's gonna check for any errors and any gaps and stuff, and it's gonna start the full process where it simulates the filling according to the part process settings. and our analysis is complete. So I'm gonna say you'll get this little summary of what the stats are and your cycle time, etc., etc. I'll say cancel. I'll say finish core cavity, and you'll see my results appear up here. I can look at the results, and here's all the results. So I'll, for example, double click on full time to activate that, and it shows me the areas of longest full time. So if we put in our gates at the corners, the areas of longest full time naturally are going to be the center. So we know to say, okay, that takes a total of 1.05 seconds to get to the center. So if there's something we need to work on, here is our plastic flow. Right, we'll see, fairly simple, not too much issues. How it flowed into the part, the confidence of flow heat map, and since this is a very basic part, the confidence of flow was very high for the entire model, so I don't have any problems here, and I can rest assured. Okay, quality prediction, you're gonna find stuff like this. We're not gonna, from inserting the mold at just these points, we might need to have in gates at here and here, because the confidence of flow isn't too great along this rib that I've created, and it's also quite a thick rib as well. Right, there might be air traps in areas that it detects, where things are meeting, and it highlights in here as shown. And lastly, we can see the weld lines, which indicates where, since I'm pouring from here and here, this is where they'll actually sort of join. It gives you a nice breakdown of what can happen. So you might want to insert more gates and more cooling channels, or depending on your experience in industry, what you'd want to change for this, based on this analysis. And that's basically a rough high-level introduction into the mold design tools in Autodesk Inventor Professional. We're just going to go back. Once again, thank you for joining us for this webinar. We leave the floor open for a Q&A session right now, but if you don't have a mic, or you can sort of just type your questions into YouTube, or you can always contact us directly. My details are here, and our office details are on the screen right now. Again, thank you very much, and we'll see you next time. Bye bye.